Hello class, I'm going to continue with on lines and planes and give some revisited. There are three types of equations that you have to know. The first one is symmetric equations of a straight line. Okay, in terms of x, y, z. And then if you consider c equals to 0, then you have only two variables. So the next one is what we call parametric equations of a straight line, where you have a parameter of t. Okay, so a here, this is what you call the directional vector. Let's recall what you did earlier for an equations of a straight line. So let's say you have y and x, and you have 2 points on straight line AB. Okay, consider this a straight line. Then you can also compute their slope. Okay, so your slope between 2 points, let's say your point A here is x1, y1, and your point B is x2, y2. So your slope would be y2 minus y1 over m2 over minus x1, x2 minus x1. And finally, you can get your equation of straight line, y equals to mx plus c. And you can always compute c. How? You choose a specific point, either A or B, and you substitute in here, and then you can compute your c. For the equations of parametric straight line, remember, for any general r, coordinate r, you can put it as x, y, or you can put it in terms of a vector because of the coordinate. For a specific point or coordinate, you can choose r0, or the coordinate is x0, y0. We look again the sample example of these equations. Okay, we want to write equations of a straight line through a point. So a given point here, usually we treat this as r0 with a slope. So you are given a slope 3/4 in terms of parametric form. So parametric form, you have a directional vector over there. Maybe let me remind you again the way you write symmetric form: x over a, y over b, z over c, and your parametric equations: x respect to a, y respect to b, z respect to c. So in this sense, you have ai plus bj plus ck. Alright, so your a is a, b, c. Now in a usual way, we start here. To obtain equations of a straight line, let's say you are given point A. You know your straight line is given by y equals to mx plus c. If you are given a slope of half, so what you do, you just substitute half here, and then you can compute c. This is easy. How? So choose again A, substitute x and y. Okay, and then you compute c. Over here is an easy example because your c is 0. So you have your equations of a straight line is y equals to half x, or you can also write down 2y over x. So this is also equations of a straight line. Similarly, if you write in terms of a symmetric form, so you know this is your slope, you can write y minus y0, x over x0. This is actually equivalent to have y2, y1, x2, x1. Analogous, okay? So in a way that you can write down, so you see what I did over here. You drop 1 here, and then you put x minus x0 to the right hand side. Okay, and this is the symmetric form. Okay, So if you solve it, you know that your slope is half. Then you always know that your slope is b over a. Okay. So then your r naught plus at, and note down your a here is ab. So a is 2 and b is 1. Okay, so you have 2I plus j. And then this one you choose whatever that is, the coordinate. Now let's go back to the question. The given is 2 and minus 3. So this is your x naught, y naught. And you're given a slope. So this is y minus y naught, x minus x naught. So you rearrange. And then a symmetric form is like this. So you have 4y plus 3 over 3, x minus 2. This is also in terms of symmetric form. But you know that this is b over a. Then you have ai plus bj. Next, for another example, we can write a parametric or symmetric form of a straight line, but you are given 2 points. So what is not known over here? You need to find the slope. Okay, so the slope, you have to use 2 points, and then you just choose accordingly. Okay, so you arrive at your m is just equals to 1. So you choose one of the coordinate. So over here I choose a. I make my r, x, y as general. Okay, I choose a1 minus 2. Okay, this one as r naught, and then my m is 1, so 1 1. So this is your parasymmetric form. In parametric form, so your a is 1 1. So you have I plus j. But let's say if you choose b as your r naught, 3 0. Therefore, you can have y plus 0 over 1 equals to x plus 3 over 1. And this is also correct, symmetric form. And your r in parametric form is, so the one that you choose, minus 3i plus 0j plus I plus j t. So whatever choice here can be varied. Okay, thank you.